guys, so what I'm going to do today is I wanted to show you some examples of rocks that I have in my very large rock collection. So I'm going to go through the different types of rock that you saw in the notes, okay? To start off with, I want to begin with sedimentary rocks, which is what you're looking at right now. Now, remember that sedimentary rocks are going to be made up of sediments, and they are compacted. That sediment is compacted and cemented together to create these rocks. So they do undergo a lot of pressure, but no heat. And because of that, in this type of rock, you will find fossils. So those are the types of sedimentary rocks that I have here. So I have, all of these are technically fossils. You can see here kind of what I'm talking about in terms of fossil. Now, can I identify these? Not all of them, but this one to me looks here like a leaf, a fossil of a leaf. This one is obviously like a shell. This one is something called a trilobite, and so is this one right here. And then this one I think is also part of a shell, just much larger. You can see a little bit of the inside right there, so you can see the fossil right there. Then I also have what's called coprolite, which is fossilized dinosaur poop, which is really, really cool. So that's coprolite right there. You will only find fossils in sedimentary rock because the fossil would not survive the heat and pressure of turning into a metamorphic rock. And it also will not survive, obviously, being melted, right? You won't see the fossil anymore after it has been melted. One other thing that I wanted to show you is this. So this is something I actually collected in Colorado, and there is an element called iridium in here, and that is an element that is very rare on Earth, but it is found in meteors. And so what that tells us is that for some reason, a lot of iridium was deposited on Earth at a certain time. And so this is evidence that a very large meteor hit Earth. And this is the meteor that actually killed off the dinosaurs. And it was actually really just part of what killed off the dinosaurs. There were other factors that contributed to the extinction of dinosaurs, but this was one of them. So what happened is the meteor came and it hit Earth. And parts of the meteor broke up into tiny bits of sediment, right? And then got deposited over a long period of time. And now we can go pretty much anywhere on Earth and you can find that iridium layer. There are some places where it's easier to find, meaning you don't have to dig. And that's one of the places where I got this in Colorado. So pretty cool. Next, I want to show you metamorphic rocks. Here are two examples of metamorphic rocks. This is probably one of my favorite rocks that I have. It's very heavy and it was hard to hike and carry this. But remember, metamorphic rocks undergo heat and pressure. So a little bit more pressure than what sedimentary, or more is happening to them than just what happens to sedimentary rocks. We also have to have heat. Now, it's not going to be enough heat to where it totally melts, but enough to where it kind of sort of melts it and it kind of melds the parts of the rock together. And so this is a metamorphic rock and this is a metamorphic rock. The third type of rock that I want to show you is igneous. So igneous rocks are formed whenever there is magma or lava that cools, and then it turns into rock. So this rock is actually from a place called Valley of the Fires. And it's in, I can't remember if it's in New Mexico or Arizona, but there was some lava flows there. And this is what cooled and became igneous rock. This one is from Oregon. And here you can see that there's lichens that have grown on it and then died. In Oregon, it's really, really moist and the lichens were really happy. But then when I brought the rock to Texas, the lichens were not very happy and they died. But we did talk a little bit about lichens when we did ecological succession, so you can see them a little bit right there. This rock right here is pumice. So it's actually really, really light, and it's formed from the ash of volcanoes. So this is pumice stone. Sometimes people use these in their gardens and they put them around like bushes or plants and things like that as part of their landscaping. I also have some ash and basically sediment that came from the eruption of Mount St. Helens when I visited Mount St. Helens, and I bought this in the gift shop. So just to review really quickly, I wanted to talk about the differences between them. A lot of the time people will come to me and bring a rock and say, Ms. Martinez, what kind of rock is this? And the first thing that I always ask is, well, where did you find it? If you found it in your backyard and it's there naturally, or you found it like out in the woods somewhere, in the monte somewhere, then it's going to be sedimentary. That's the only type of rock that we have here. And you will find fossils here in Eagle Pass. You just have to look for them because this whole area used to be ocean. So you will find ocean organism fossils in the rocks around here. So chances are if you find a rock here, it's going to be sedimentary. You can also find igneous rocks relatively close to us, not necessarily in Eagle Pass, but if you go closer to the Uvalde area, there are extinct volcanoes in and around Uvalde. So if you look around, sometimes you'll see these hills that kind of pop out of nowhere and they're just all by themselves. It's actually an extinct volcano. So you can see these extinct volcanoes near Uvalde. Metamorphic rocks are hard to find, which is why I was super excited when I found these metamorphic rocks. You're going to see some striping sometimes in metamorphic rocks, or you're going to see kind of like these little spots that look like they're extra squished. And that's the easiest way to identify metamorphic rocks, at least for me. Now, I am not an expert, but it's pretty tough to find metamorphic rocks because you have to be in an area where you know there was extra heat and pressure at one point in time to have formed that metamorphic rock. Now, there's a couple of other things that I wanted to show you. This is actually a meteor. So this is something that you might also find, when you're looking around at stuff. And the reason that I know that this is a meteor is because it's obviously not made from sediment. It doesn't look like rock. It actually looks like metal. So meteors are going to be mostly iron. So they're going to have this kind of like brownish, reddish tinge to them, and they're going to be pretty round looking because they become a little bit molten as they're traveling through Earth's atmosphere. And so you will find meteors every now and then. Every time you see a shooting star, that's a meteor. Most of them will burn up in the atmosphere and you won't be able to find anything. Sometimes they do hit Earth, and if you're really careful and you pay attention, when you look down, whenever you're going on a hike, you might find a meteor, and it's going to look something sort of like this, but probably a different size. So this one's kind of rounded on this side, but then it's also been kind of broken up on the back side. Here is some petrified wood that you can see looks like a tree trunk or tree branch, right? So this is also a fossil. It used to be a tree. And this is actually store-bought. You can see that it's kind of been shined and it's got a label on it, but you can find this stuff too. So pretty cool. Wherever there used to be an ancient forest. Something else that I wanted to show you was rocks from the ship that I was on, the Joydes Resolution. These are what are called gabbro. I talked about them in the notes. And they are also igneous rock. It's a very hard rock. This is one of the drill bits that the Joydes uses. This is actually for sediment, so not for hard rock. This is not strong enough to go through hard rock, but a drill bit will actually have 3 or 4, I can't remember, sorry, but 3 or 4 of these drill heads on it in order to drill to the crust. And so this is what we were drilling through to get through the crust. Whenever it gets closer to being the mantle, it's gonna have a kind of a greenish tinge. like this guy right here. Now, this is from a gift shop. Actually, one of the scientists on board gave it to me, and it's been shaped into this shape and it's been polished. But you can see this green right here, and that's a mineral called olivine, and that's how we know it came from the mantle. That mineral is present in the mantle, and what's happened it has cooled. Now, because I have this rock, does that mean we've gotten to the mantle? No, there are some areas on Earth where there's been uplift. So basically, the crust and part of the mantle, the very bottom part of the crust that's touching the mantle, has actually been pushed and exposed. And there's parts in England or areas in England where you can actually see this part of Earth that used to be very, very deep and was part of the mantle. And so that's where they collect these rocks that have this kind of greenish tinge to them because of that mineral. Sometimes we also have volcanoes that will spit out what's called peridotite. It's these green looking gems. If you're born in August, then you know what I'm talking about. That's your birthstone. And so we know that that's actually coming from way down deep, that the volcano spit that out, and it was actually coming from the mantle. It wasn't anything that was closer to the surface that was in the crust. So that's really cool. Here is the pipe that we actually use to drill, right? This is where the rock goes in. So you can see, if I take off the top, of the tube, you can see that it's the same size as the rock. And this rock was actually given to me by Jason. Okay, so these are just some of the rocks in my collection. I really like rocks. I could talk about rocks forever, but we don't have time for that. I hope you enjoyed this video, and I'll see you guys soon. Thanks.